based on mechatronics subject, and the name of topic is architecture of PLC. Okay, so architecture of PLC. A programmable controller can be studied by considering the basic elements shown in figure. So the PLC consists of basic elements like the processor, input output modules, and the software. So these three are very basic elements of PLC. So you can see in the center processor is shown, which is connected to programming software. Okay, on left hand side you can see input module channels. Okay, so there are channels, channel 1, channel 2, channel 3, where we connect input devices. Okay, and on right hand side there is output module channels, channel number 4, 5 and 6, where we connect output devices like motors, solenoids, valves, light bulbs, etc. Okay, so like this is architecture of PLC, or we can say basic block diagram of PLC. So what are the components in PLC? The components are input module, output module, CPU, memory, power supply, programming device, communication channel, etc. So this is the diagram of PLC consisting of all these components. So here this is input module, okay, where you can see many input sensing devices are connected. You can see different types of switches are there which are connected to this input module. Also on output side you can see there is output module is shown, which is connected to output load devices like motor, solenoids, light bulb, etc. In the center you can see there is CPU and memory is shown. Okay, so this is CPU and memory is here, where we can store the program or data, and which is connected to programming device. So here some device is required for programming, and everything is operated with the help of power supply. So we require power supply for all the operations. Okay, so like this components in the PLCs are shown over here. So input module, what is input module? So figure shows the typical wiring to a PLC input module. The input module examines the state of the physical switches and other input devices and puts their state into a form of suitable for processor. Okay, so this is diagram of input module. So what is here? The switches are there, physical switches. Okay, these are switches. All the three switches are connected here to particular channels, channel 1, channel 2 and channel 3. Okay, so these switches put their states into a form suitable for the processor. Okay, so you can accommodate number of inputs called as channels over here. So this is input module. You can accommodate 10 to 20 channels in one input module. Okay, so if the switch is closed, the input will be 24 volts, DC, and if switch is open there will be no input, that is 0 volt DC. Okay, the input module converts this into the 1 or 0 state needed by the processor. Okay, so like this, if switch is closed there will be 1 position, and if switch is closed there will be 0 position that is needed by the processor. Okay, so like this input module works, where we connect different types of switches to input side and converts them suitable for the processor. Okay, so the input module convert real world voltage and currents to signals that PLC can understand. Okay, so it converts real world voltage and currents that PLC can understand. Since there are different types of input devices, there is wide variety of input modules available, including both digital and analog modules. So there is both type of modules are available, digital and analog modules, and it can depict the state 0 and 1 only. Okay, and analog module uses numbers to depict state, for example 30 degree, 40 degree, 50 degree. This can be detected and converted into proper signal. This is the diagram for input module. So here we connect different types of switches in different types of slots. Okay, so switch having 24 volt DC is connected in particular slot. Pressure gauge is connected in the slot where it can measure 4 to 20 milliampere range. Temperature can be recorded as a 0 to 10 volt DC, and they are connected in particular slots in input module. Okay, similarly we have to study output module also. So the figure shows the typical wiring to the PLC output module. The output module supplies AC power to the external devices such as motors, lights, solenoids. So here you can see motor is there, solenoid is there, light is there. So all these are connected on output side of the output module. Okay, so there are channels are there where the output devices are connected, and all the devices receive signal from the processor. Okay, processor gives signal to the output devices. The output module accepts 0 or 1 from the processor and uses it to turn on or off a device. So all these output devices turn on or off depending upon 0 or 1 position. Okay, an output module can have one or several channels per unit. Each channel is usually provided with an indicator light to show whether the particular channel is being driven on or off. So there is one light is also provided to show whether particular channel is working or not. Okay, so the output module consists of different slots. Okay, so in the different slots different output devices are connected. Suppose valve is shown here. Valve requires 0 to 10 volt DC supply, fan having 120 volt AC supply, and light having 24 volt DC. Okay, so like this output devices are connected in output module. Now processor. The processor is a computer that executes a program to perform the operation specified in ladder diagram. So program is done in the form of ladder diagram, and to perform this program we need processor. Okay, so it performs arithmetic and logic operations on input variable data and determines the proper state of the output variables. Okay, so it performs all the operations, logic and arithmetic operations, and determines proper state of the output variables. This is the work of processor. Now CPU and memory. So what is CPU? CPU is the brain of PLC. Okay, that is central processing unit. It executes various logic and sequencing functions by operating on the PLC inputs to determine the appropriate output signal for the actuator. Okay, so it performs various logic and sequencing functions. Okay, the processor is microprocessor, very similar in its construction to those used in personal computers and other data processing equipments. Okay, so CPU is something like microprocessor which performs all the types of data processing activities. Now memory. What is memory? Memory is tied to the CPU is the PLC memory, which contains the program of logic, sequencing and other input output operations. So memory consists of all types of programs. The memory for PLC is specified in the same way as for computer, range from 1 kilobyte to over 48 kilobytes of storage capacity. So it may have high storage capacity. So this is the CPU and memory of the PLC. Now for working of PLC we need power supply. Power supply of 115 volts is used to provide power to the PLC and any other modules. The power supply come in various forms. So you can see here power supply modules that fit in one of the slots in a chassis. So this PLC has chassis, that is slots are there. In that slot the power supply modules can be fitted, or you can use external power supply also that mount outside of the chassis Stand-alone power supplies that connect to the PLC or input output through a power cable. So stand-alone power supplies also can be used, or you can use embedded power supplies also that comes as a part of PLC block. Okay. So this is related to power supply. Programmable device. The PLC is programmed by means of programming device. We need one programming device for PLC programming. The PLC programming device may be detachable from the PLC cabinet so that it can be shared between different controllers. Okay, it can be detachable also. So different PLC manufacturers provide different devices. So there are two types of devices are available. One is simple teach pattern, which is usually used in robotics. Okay, or you can use PLC programming keyboards and CRT displays. So both the methods are available. Okay, for programming device. Communication channels. Now we need to communicate the signals from one point to another point. That's why we require communication channels. So we can use data bus for sending data between constituent elements. We can use data bus also. We can use address bus for locating different addresses of stored data. Control bus can be used for different control actions. System bus is used for communication between input and output ports. So like this, there are different types of communication channels are available. So the bus means what? The bus are the paths for communication within the PLC. Bus is nothing but paths for communication. The information is transmitted in binary form as a group of bits. Binary form means what? It is group of bits with a bit varying between 0 and 1. So the term word is used for the group of bits considering some information. So the 8-bit word means what? It is the group of 8 words, that is 0 and 1s. Okay, this is called as binary number. And each of bit is communicated simultaneously through the parallel wires. So each bit is transmitted simultaneously, its own, on parallel wires. Okay, on parallel wires some communication is done. So this is one diagram of communication channel. So here you can see different buses are provided. So there is one bus is provided. This is this is address bus. Okay, then there is one control bus is there. Then data bus is required for communication between different blocks. Then input output system bus is there. Program panel is there. Okay, so and in between them, these are all so in between them all the blocks are provided. So now there are PLCs having different types. So first type is single box type. The single box type is commonly used for small programmable controllers and is supplied as an internal compact package complete with power supply, processor, memory and input output units. So single box types means what? It consists of all the units inside in it. That is like power supplies inside, processor, memory, input output units, all are contained within one compact package. Okay, typically such a PLC might have 6, 8, 12 or 24 inputs. So like this it may have up to 24 units inputs and up to 16 outputs and a memory which can store 300 to 1000 instructions. Okay, this is called as single box type PLC. And there is another one is that is modular type. So the modular or rack type consists of separate modules for power supply, processor, input, output, module and memory. So it has separate modules for each and every units. It is called as modular type, that is rack type PLC. So you can see the diagram of brick type PLC. So it consists of all the input output modules, memory, everything inside in it. And this is rack type PLC. So it has some slots or racks provided for connecting input output devices, memory and all other things. So these are types of PLCs. So thank you so much all of you for watching this video of architecture of PLC. So thank you so much.